Hi everyone, this is Mrs. Dever again. Yesterday in the last section we were talking about measures of central tendencies. We were talking about mean, median, mode, where the data is centered. In this section we're going to look at how the data is spread out, and there's two ways we're going to talk about that today. The first one is really easy, and it's something you've probably known since grade school, and that's the range. When we take the largest value minus the smallest value to just find out that length, that difference. So here we have two pieces of data. We have the selecta discs. Let's say this is how much we can buy this for each month. And then we have the discount discs and how much we can buy these for each month. Well, let's talk about mean. We already know how to find the mean, the average. We add up the total and divide by the number that we have. And because we're talking about the 12 months, we divide by 12. So I added all these numbers up and I got 372 divided by 12. The mean ends up being 31. Let's find the mean of the discount discs. Once again, I would take all these and add them up. I've already done the work. When I added all these up, I got 372. What divided by 12 is going to give us 31 again. So these two sets of data have the same mean. Range. Range, the largest value minus the smallest value. So 100 minus 21 is 79. And the range for the discount disc, well, let's see, the highest price was 80. 80 minus 1 is also 79. So these two pieces of data, these two sets of data have the same mean and they have the same range, but if you actually look at the data itself, it looks extremely different. So there's got to be a better way to compare this so we can describe the difference between these two. And that is called the standard deviation. So the formula for a standard deviation looks very complicated. So we're going to break it down into parts. We have the variance, this s squared. Remember sigma? Sigma means we're adding things up. We talked about sigma back when we were doing arithmetic series and geometric series. Also, a reminder that this notation represents the mean. So when we see that here and here, that represents the mean. The n represents the number of data points we're talking about. So in the last example, we had each disk had 12 data points. When we take the square root of the sample variance, we get what's called the standard deviation. And today we're going to learn how to calculate it. Later on, we're going to learn how we can use this in more depth. Example 1. Edgar and Ann are travel agents. They recorded the number of international airline tickets each sold for the last 5 months. So we're going to compare these. We're going to look at their averages, and then we're going to look at their standard deviation to see what the spread difference is for these two. Okay, let's find the average first for Ann. Ann's mean. I'm going to add 10 and 4 and 12 and 0 and 18. And when I did that, I got 44 divided by 5. Ann's mean is 8.8. Now, to find the sample variance, I'm going to use this formula. And it looks really complicated. I've got the sum of parentheses x minus the mean quantity squared all over n minus 1. So we're going to break this down. And that's what the chart is for, to help us break this down. Ann's tickets, well, she sold 10, then 4, 12, 0, 18. The order of this column does not matter. I went ahead and put it in the order the original data was in. Some people like to put this in order from smallest to biggest. It really does not make a difference. Okay, the second column is how different is this from the mean. How far off are we? So we take our data, the 10 for this first one, and subtract the mean, 10 minus 8.8. And when I do that, I get 1.2. The last column says take that number and square it, so 1.2 squared. I'm going to do that for all 5 pieces of data. So 4 minus 8.8, that gives me negative 4.8, and I'm going to square that, 23.04. Now, if you got a negative 23.04, it's just because you didn't have negative 4.8 in parentheses on your calculator. But you know that anytime you take a negative number and square it, you should get a positive number. So this squared deviation column should always be positive. I continue on, 12 minus 8.8. That gives me 3.2. Square that, 10.24. 0 minus 8.8, well, that's easy, negative 8.8. Square, once again, we're squaring a negative. We know that that answer should be positive. I get 77.44. And then finally, 18 minus 8.8, which is 9.2. Squared is 84.64. The sample variance calls for the sum of all these values we found in our squared deviation. So I'm going to take all 5 of these numbers in the last column and add them up. This sum of the x minus the means squared, when I added them all up, I got about 196.8. That 196.8 is my numerator for the sample variance, that's sum, and my denominator is n minus 1. Now think what we said n was. N was the number of data points. We have 5 data points, so n is 5, which makes n minus 1 4. That gives me 49.4. So my sample variance is 49.4. The standard deviation, I simply take my answer from the sample variance and take the square root. So the square root of 49.2 is about 7.0. So once again, the sample variance and the standard deviation deal with the spread of the data. So let's compare the spread of Anne's data, this 7 that we got, with the spread of Edgar's data. We're going to do the same process. Okay, here's Edgar's information. So he sold 8 long international airline tickets, then 9, then 12, then 7, then 8 on consecutive months. So I would take the data and I would add it all up. 44 divided by the 5, 8.8. Now, that should look familiar. Anne's mean was also 8.8. So they happen to have the same average tickets sold. But let's compare their spread. Look at Edgar's data, 8, 9, 12, 7, 8. Look at Anne's data, 10, 4, 12, 0, 18. Who has the bigger spread? Well, Anne's ticket sales vary a lot more. So she seems to have a bigger spread than Edgar, who always sells about 8, 9 in that area, approximately. So it seems like he should have a smaller spread, which would imply that his standard deviation should be smaller. So let's check that out and see if that happens. So Edgar sold 8, 9, 12, 7, and 8. Let's find the deviation from the mean. How far off was he from his average? Well, here he was negative 0.8. Squaring that, once again, gives me a positive 0.64. 9 minus 8.8, once again, a very small difference, just 0.2 off. Squaring that gives me 0.04. 12 minus 8.8, that's 3.2. Squaring that is 10.24. 7 minus 8.8, negative 1.8, squaring gives me positive 3.24. And finally, 8 minus 8.8 again. Squaring that gives me 0.64. Now, my sample variance formula calls for the sum of these numbers. So I'm going to take all 5 of these numbers and I'm going to add them up. When I add them up, I end up with 14.8. That's going to be the numerator for my sample variance. My denominator, once again, I'm still working with 5 data points, so 5 minus 1. That's about 3.7. The standard deviation is simply the square root of the sample variance, about 1.9. So we said Edgar's data was closer together. His standard deviation was 1.9. Anne's data had a much less consistent pattern, a lot further away from the mean. Her standard deviation was significantly bigger. It was 7. Okay, let's try one more problem together, and then I'm going to give you one to try on your own. Petroleum pollution in oceans is known to increase the growth of a certain bacteria. Brian did a project for his ecology class in which he made a bacteria count in 9 random samples of seawater. His count gives the following readings. Find the range. Well, range, biggest minus smallest, that's a very simple calculation. Our largest data is 23. Our smallest data looks like it's 12. So the range would simply be 11. Okay, next, the sample mean. Mean is the normal average we're used to thinking about. I'm going to take the total of all these scores. So I grabbed my handy calculator and added everything up. Divided by the number of data points. Well, it tells us there's 9, or we could count that there's 9. So our average is approximately 17.7. So let's go ahead and calculate the standard deviation. I'm going to go through the same process. I'm going to take 17 minus 17.7. When I do that, I get negative 0.7. Squared is 0.49. 23 minus 17.7. Well, that's 5.3. Squared is 28.09. I continue this process. 18 minus 17.7. 0.3 squared is 0.09. 1.3 squared is 1.69. Negative 1.7 is 2.89. Negative 5.7. Anytime I'm